So we divide it up into three sections. We have width, we have length. Now, you have to begin to look at these problems and understand what's driving the problem. This, my folks, is driving the problem. What is our objective? Maximize the area. So we need an equation. We need an equation for area. Area is equal to what? Shelby owns it. Nice job. Oh no, I've got two variables. Two variables does me no good. I need one variable. How in the world can I rewrite area so that I only have width or length? This is the magic. Close. Good try. Use something else in the problem. Four W plus 2L is equal to 480. You see, folks, if you have two variables, you need two equations in order to write it as one variable. That's how it works. So we're going to say that there are four W's used in order to create the pens, and there are two L's used to create the pens. You're in agreement? So now I'm going to solve for L or W. Which is easier to solve for? Solve for L. 2L is equal to 480 minus 4W. Or L is 240 minus 2W. What do you think we do with that? Plug it in for L. Now I have a function in terms of area. Area in terms of which variable is left now. Which is the variable that we'll be working with? What's the variable that will be within our equation? W. Area in terms of W is 240 minus 2W times W. Or area in terms of its width is 240 times the width minus 2 times the width squared. Our goal is to maximize the area. This is the area. I would like to find where this area has a maximum. Do you have any idea what this shape looks like? Parabola, writes it up or upside down? Upside down. So does it have a minimum or a maximum? It has a maximum. Man, I wish we had a name for that maximum. I wish we had a name for that spot on the... Wait, it's called the vertex? Goodness, I wish we had a handy-dandy formula for the vertex of a parabola. Negative b divided by 2a. Oh my gosh. We roll. Negative b, negative 240, divided by 2a, negative 4. And I get 60. I sold 60. Nobody got it. Nobody got it. I sold 60. You ever seen the Girl Scout cookie fail? I'll bring it up. I sold 60. You got it? Okay, I'll show you. It's hilarious. Okay, so this vertex has a coordinate. It's got a coordinate of W and A of W. So we just found the width. The width is 60. But here's where you got to pay attention. If you plug 60 back into here, what would you get? Don't give me a number, give me a representation. What would it produce for you? The area. Did we want to know the area or did we want to know the dimensions? The dimensions. We have width is equal to 60 yards. So the length is equal to, how do I determine the length? Right. 240 minus 2 times the width is the length, right? Like this thing right here, it tells me. It's saying, hey, I'm length, use me. 240 minus 120 is 120, 120 yards. Boom. Folks, we divide up into 4 boxes. That's what I did my graduate work on, to see if dividing things up into 4 boxes using graphic organizers in different situations actually impacts your learning for the better. What we found out is that it does. So I always take word problems, I divide them up into 4 boxes. I model it, I write my formula and my relationship, I then make my function, and I solve. Guess what? We find out that kids can do this really well, and kids can do this really well, and kids can do this really well. This is the difficult part. That's where the magic happens. That's what we have to figure out. So we're going to give you a chance to figure out box number 2 on your own. I'll walk you through a couple, then you try. Sum of 2 numbers is 24. Find a function that models their product in terms of x, one of the numbers. Can you give me an equation where the sum of 2 numbers is 24? X plus y is 24. Find a function that models their product. So this is what's driving the problem. The product. Give me an equation for the product. Product of the 2 numbers is x times y. The sum is x plus y, which is 24. The product is x times y. The difference is I want the product just in terms of x. I don't want y. So the product in terms of x is x times, what do I put in place of y? If you were to solve for y here, you would get 24 minus x. Very good. See it? Always use your secondary equation to be able to write the other one. A picture is 8 inches longer than it is wide. We have length and we have width. Find a function that models the area of the picture. That's what's driving the problem, the area. So I write area is equal to length times width. Hey, I don't want to have length in the problem. I want to have width. So area in terms of width is width times, what do I put in place of the length? W plus 8. Uh-oh, let's try one that's a little bit more challenging. Rectangle has an area of 40. Find a function that models its perimeter. Perimeter is what's driving the problem. Give me a formula for perimeter. Two L plus 2W. Okay. So I want to substitute something in for L or for W. Can anybody think how I could use this to come up with another equation? L times W is 40. Would you like to solve for L or W? Would you like to read L equals or W equals? It's up to you. I don't care. Okay, so I'm going to divide both sides by L. So I got W is equal to 40 over L. What do I do with that 40 over L? Plug it in for W. So the perimeter in terms of L is 2L plus 80 over L. Easy when your teacher walks you through it, right? What if you had to try it on your own? Go. Try the next one. Okay. Rectangular box. See if anybody got it. I know it's tough to do on your own. It's easier when you see a direct example. But eventually you want to try to come up with stuff on your own. So hopefully you understand volume is equal to base, or I should say length times width times height. Well, in this situation, the bottom is the same, isn't it? And the height is just 3 times one of those. So volume in terms of x is 3x cubed. What I'm going to try to show you as many examples of different types of problems that have these types of formats. But at the end of the day, you want to try to come up with that aha moment on your own. And that's really the measure where you're at. Well, I'm saying if you want to be a top level mathematician, yeah, you want to be able to start to figure out problems without teachers showing you how to do them. Yeah. So, however, we're not ready for that. So let's show you a couple. We'll do two. Farmer builds a fence against a barn. Hey, look at that. He's getting smart. He's like, if I've got a barn, then I don't have to use fencing against the barn. I'm going to save some product. Okay. So I've got width, and I've got length. You tell me, where do I begin? Where do I start? This is just slightly different than the first one. I know you can do this. Where do I start? What's driving the problem? Maximize area. So what do I write? Very good. Area equals length times width. Shoot, I got two variables. Now what? Two W plus L is 320. Good. I've got a secondary equation. Now what? Good. L is 320 minus 2W. So area in terms of width is equal to 320 minus 2W times W. Or area in terms of W is 320W minus 2W squared. My goal is to do what? Maximize the area. Do you know what that shape looks like? Parabola, right side up or upside down? Great, it has a maximum. If it didn't, that would be a problem for me. Now what? How do I do that? Negative b over 2a, negative 320. Divide by 2a, negative 4. I get 80. What does 80 represent? The width. If I plug it back into this, what would I get? The area. Do I want the area? No, I want the dimensions. So it's going to be 80 feet by what? Length is sitting right there. It says length is 320 minus 2W, so 320 minus 160. You got that grand total of 160 feet. Good job. Good work. We have time for one more problem. On Monday, we'll roll through 3. You've already seen one similar to 5 in a previous time in this class. Box is to be constructed from a rectangular piece of cardboard with dimensions 10 by 18 by cutting a square from each corner, folding up the sides. Do you recognize this problem? Good. That's why I prepared you for it. So I'm going to draw this rectangle. You see in the first box, we model the problem, so we get a picture of what's happening. I'm going to cut the corners, so I'm going to call it X by X. Can somebody tell me what else I should maybe put on this drawing? 10 and 18, good. Like the way you think. Great. I've got the general idea. But now I've got to move over to this formula, this relationship piece. I've got to come up with some type of equations. What are you going to start with? What's driving the problem? Largest volume. So V equals length times width times height. When I cut stuff off the corners, is it going to be longer than 18, 18, or less than 18? Less than 18. How much less than 18? 2x. Good job. Length is 18 minus 2x. How about the width? 10 minus 2x. How about the height? X. So that means I have volume in terms of x is 18 minus 2x times 10 minus 2x times x. Negative 2x times negative 2x is 4x squared times x is 4x cubed. What are you going to get in the middle? As I FOIL this guy out. Negative 36 and negative 20, which makes negative 56 multiplied by the x, we get negative 56x squared. And 18 times 10 is 180. I multiply by x, I get 180x. Does that make a parabola? Shoot. If you factor out x, you would get x squared, but it's still x cubed. The deal is the shape looks like this. Not everything we get looks like a parabola. What do we do if it doesn't look like a parabola? It's still a maximum. How do I find it? Calculator. We do not use negative b divided by 2a. You get out that graphing calculator, you plug it in. 4x raised to the third minus 56x squared plus 180x. Zoom 6. Uh-oh. You see, we're almost to the problem, or we're almost ready to answer the problem. But we got to be smarter than the calculator, folks. You got to be smarter than the calculator. Think about it. What's the biggest x value you could have here? What's the most you could cut off? 9, right? What's the most you could cut off here? 5. So if x at most could be 5 or 9, is it okay that I have my x window at 10? Yeah, I could see everything I need to see. But let's think about the y value. Carson, how much do you want to cut off? Give me a number. 3. Carson wants to cut off 3. If Carson cuts off 3, what's going to be the width? 4. What's going to be the length? 12. So the volume would be 12 times 4 times 3, which is 144. So our volume is not in the tens. It's not in the thousands. It's most likely in the hundreds. Would you agree? So that means that my window, my y values, I should move up into the hundreds, greater than 144. What do you say we move to, like, I don't know, 250? Does that sound okay with you guys? I'm kind of taking a guess. I'll make a scale every 10. No, how about every 100? Press graph. Do we see the parabola now? Hey, there we go. How do we find the maximum? Second calculate, go Nicole. 4. Move to the maximum. Left bound, I move this way. Enter. Right bound, move this way. Enter. Enter on guess. And I get this coordinate. 2.06, 168.13. What the heck does that mean? What does the 2.06 mean? That's the x value. That's how much you cut off. Carson guessed 3. It's a good guess. Turns out 2.06 is best. What does the 168.3 mean? That's the y value, which is the volume. What's the problem asking for? Volume. 168.13 inches cubed. Done. Good job. This is not easy stuff. But generally people do better with these word problems than they did the first time around. I think you can handle it. If you notice, we are done with quadratics. We are into the applications of min and max. After Monday, we'll be ready to move on to 2.8. So this is not easy stuff. Stay on top of it. Make sure you enjoy a good weekend of some math homework.